Hello, this is going to be a really short video today because this lesson is mostly just for you guys getting practice. We're not really learning anything new. I'm just going to record this video kind of going over this review and then kind of explaining what you guys are going to be doing, maybe doing one of these examples for you, okay? So quick review, what are the 5 shortcuts for proving two triangles are congruent? Draw a picture to represent each one. Wow, so we have to draw 5 shortcuts and don't have that much room here. So let's do this. So we've got side, side, side. All right. So what in the world? That's not a triangle. All right. Side, side, side. It would kind of look like this. All right. Basically, you know all 3 sides, right? Then we've also got side, angle, side. I should have done this before I drew on it. Okay, that's bad. Should have just drew my own triangle. All right, side, angle, side. So how would this look? All right, you would have this. All right, so a side, an angle, and a side with the angle in between the 2 sides. Then we've got angle, side, angle. So that would look like this, right? And then we've got a side, and then we have another angle, and the side is in between the 2 angles. Then we've got angle, angle, side. And so for that one, we have 2 angles, except the side is not in between the 2 angles. So the side that we have would be over there. And then the last one is hypotenuse leg. All right, and hypotenuse leg is only for right triangles. And we have one of the legs, and then we have the hypotenuse. So those are the 5 things that we have. What are 2 shortcuts that cannot be used to prove 2 triangles are congruent? So the ones that you cannot use are SSA or AAA, right? So if you're trying to use one of these 2 right here, you can't do it. You got to say not congruent. These are the only 5, all right, that you're allowed to use. So look up here, all right? Now these pictures are going to be a little bit different than the pictures that you saw, but that's okay. So what we're going to do is first we're going to write the postulate or theorem that says that they're congruent, or just say not congruent. Okay, that's okay too. Then we've got the congruent statement, all right? So that's kind of like what we did on Tuesday. And then what is the transformation that would actually take one triangle to the other? And it doesn't have to be difficult, all right? It's just one of the 3 translations, reflections, or rotations. So let's do the first one together, okay? Now, when I'm just looking at this, what do I see right now? Okay, well, I first of all, I see a side, right? And that matches up with this, okay? So I've got 2 sides. So remember, these are my 2 triangles right here, right? So right now I've got 2 sides. Then I have these 2 lines over here, so I have another side. So right now I have 2 sides, all right? So it's either going to be side, 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 or side, angle, side, or nothing, right? Now, sometimes you have to look at this and you have to draw stuff for yourself. I told you in the beginning of the year, one thing that you always need to recognize is vertical angles, right? Vertical angles. So those 2 angles are actually the same, all right, which means that we have angles here. So what do we have? All right, we have side, angle, side, okay? And then you can look at the other one, side, angle, side. So whatever you have, you should have it twice in both triangles, right? So you can't go from one triangle to the other. You got to keep them separate. So this one's going to be side, angle, side, right? Now, writing a congruent statement, okay, might be a little bit difficult. The first triangle that you use for your congruent statement, you can put it in any order that you want. So I might say triangle BKC, right? Triangle BKC. And that's going to be congruent to what, right? Now, remember, you have to match up the letter. So what letter matches up with B in the other triangle? Now, you might be tempted to say U because it's a cross, but, all right, look at the path from B to K, right? The path from B to K goes across the 1 tally mark. The path from U to K goes across 2 tally marks. So U actually does not match up with B because BU is not this, or sorry, BK is not the same as UK, right? Burger King is not the same as United Kingdom. So B is actually the same as S down here, right? You can see those are both the lines with 1 tally mark. So BK actually matches up with SK, right? So we're going to start with S, right? And then K is in the same spot for both triangles. These 2 angles right here, this angle and this angle, are both the same. So K matches up with itself. So we're going to have BK matches up with SK. And then the thing we have left is C, and C matches up with U. All right. So this congruent statement is BKC matches up with SKU. Okay. And the last thing, the transformation. This is not going to probably be on your test. I say that. No, I'm not going to put it on there. But it's just kind of to get some more practice with transformations, because transformations are important. So how do we get from BKC to SKU? Well, there's really, it's not a translation, right? So there's kind of 2 options. Is it a reflection, right? Well, it's not a reflection, because if it was a reflection, B would be going to U, right? If it was a reflection, and C would be going to S, but we know that wasn't the case. So it can't be a reflection. So the only thing left is rotation, right? And so it's actually a 180-degree rotation, because this would rotate 180 degrees to S, C would rotate 180 degrees to U. So the answer for that one is rotation. All right. So I want you guys to try this, all right, on your own. The only hint that I'm going to give you, all right, is there's a couple of them, all right, 9, 8, 5, and 2, right? What do all those have in common? The triangles are right up next to each other, okay, like this. What that means is they share a side, all right? And anytime triangles share a side, you can actually count that triangle, that side is congruent to itself, right? That's where we learn the reflexive property. So that side actually counts as being a side for both triangles. So like for this one, you have this angle, then you have this side, and then you have this angle. So you can figure out what that one is. But that is how you do this. Give it a shot. All right, we'll go over it on Friday. All right, in class. So if you're having questions, make sure you come to the Zoom. If you have any questions, let me know, and have a great day.